Okay, let's apply and welcome Daniel editor. And his presentation, Improve Code Quality through Static Analysis for Python. Okay.
Okay. Hi, everyone. I'm Daniel Izquierdo. I come from Venezuela, and I'm living in Japan right now. I'm a developer at a startup based in Tokyo called MakeLeaps. We develop business software for primarily for businesses that are in Japan. And we're very much a Python shop. Our main product is a Django web application, and we have also some supporting tools and utilities written in Python too. And that's my email and my Twitter handle. So, well, basically, static analysis means doing interesting things with your code before running it. So it means taking the source code of your project and maybe reading it and analyzing and extracting, or getting useful information about it, or doing modifications to it without the need to execute your program, which might be more expensive. And why this talk? Given that there's many things you can do with static analysis, the main goal of this talk, as the title suggests, is I hope you can walk away from here by integrating the use of static analysis in your project to improve quality, and that means a different thing maybe for different people. Like your standards for software quality might be different depending on the project. But yeah, the main idea is you should be able to reduce the number of errors that you ship in your software, and ship more confidently and ship faster, and preventing errors in production systems. So, for example, running your code or running unit tests can also help you find problems. So why static analysis? Well, there's many different sort of problems that can be found doing static analysis before the code is shipped. So, for example, you can find errors in your source code, even if you're not unit testing a piece of it. So, if you have an untested function and there's an undefined variable there, static analysis can help you find that. It's also reasonable to ask for static analysis to find security issues in your source code, right? So if you, for example, if you're using a database querying function and you're doing string interpolation in the query that you're passing to it, then maybe automatic analysis of your source code could help you find this, whereas regular unit testing wouldn't. There's also the problem of code complexity. So yeah, that's a very deeply nested if statement. In general, there's many different also ways to measure complexity. But I mean, at least we can all agree, for example, that this function is kind of hard to maintain. You could also be having very similar code. For example, like a 10-line snippet of code that shows up multiple times in your project. Or so for example, maybe that means that's a function that could be refactored and be called from everywhere instead of repeating the code, or that sort of thing. So static analysis can also help detect those sort of issues and help you refactor. Keeping code clean. If you care about, for example, not having unused code in your file, static analysis can help you find that. Yeah, so that's a very simple example. But it can also help you find bugs, even if you're not testing a function. So in this example, maybe you can notice that I define a couple of variables, and then I define a date range, and I'm doing like date begin in both sides of the date range, right? So in this case, a static analysis tool would tell me, you're not using the date end variable. In this case, maybe this unused function was just there remaining because of some refactoring or something. But in this case, it's actually highlighting a bug. Like I will look at this and say, oh, why am I not using the date end variable? Oh, it's because I accidentally didn't use it in the line where I should. So that sort of trouble can also be found. Also, enforcing coding style. So again, if some people care about a consistent coding style just for readability and maintainability. So if you have a simple rule like you want to preserve the indentation, the levels of indentation in your source code, well, static analysis can help you find that too. Find work that needs to be done. As simple as something that tells you about all the to-do comments in your project. So if you want to be maintaining like a low level of pending work, yeah, then it's possible to do that. And there are also many other functionality that can be done by static analysis, like calculate code metrics, meaning you want line counts, function counts, number of methods per class, or that sort of stuff. Index and search code. If you're building a code search tool, then just building a tree of all the functions, methods in your source code is basically doing static analysis on it. Refactor, so there's code refactoring tools where if you wanna rename a method, so you want to get all the usages of that method, but not just do like a blind search and replace on your code, then that's also static analysis. And of course, this is not the limit, right? There's probably many more other things that you can do. So there's various popular static analysis tools for Python. I'm listing a few of them here. If you start searching around, you will quickly find many more. So this is just a small list to give an example. There's Pylint and PyFlakes, which help you find errors, such as like the one I mentioned before about like undefined variables. They will help you find those. There's PEP8 and PEP257, which basically help you find deviations from, of course, the PEP8 specification for coding style, or PEP257, which is for docstring style. So there's Flake8, which kind of combines PyFlakes with also PEP8 coding style deviation search. MacCabe, which is more a code complexity analyzer tool, so it can help you find spots that you maybe should be refactoring. So I will give a small example about Pylint, which is the main tool that we're using at MakeLibs. So if you have a pretty small snippet of code, it has various problems, and probably maybe at a first glance you can tell a few of the problems there are, or maybe some of them will escape you. And of course, this is a small snippet, but static analysis can help you with a far greater impact if you have a very large code base, right? So for an example run of Pylint on this code, I kind of snipped it a bit, so this is just to highlight a few of the problems it can highlight. Yeah, I created a class, without inheriting from object, so where I was actually intending it to inherit from animal. There's that, the second message, which is like I defined a method and didn't use self as the first argument. That could have been because I just didn't follow the convention, but we all follow that convention basically, right? So it was, in this case, it's more about the fact that I just forgot to add it, right? And then when I call it, it's going to have problems. Using this loop variable that's undefined, it will usually be defined, but if I don't enter the for loop, of course, it's not going to be defined, and the unused import, right, of animal. So yeah, just like a quick run gave me a very useful list that I can act on. This is sort of important because for some other languages, the compile step would have found many of these sort of issues, right? So given the nature of Python, static analysis tools are in a way taking over the job of a lot of what the compiler would be doing otherwise, before we need to actually run this code. So yeah, if I just go and modify the snippet I just put, and just Pylint will give me a blank output, and I'm good to go. Because of the nature of Python, it can be hard to perform static analysis in a way that finds all problems that you might be interested in. So as I was saying before, we are a Django shop, so I put a little snippet here of some Django code. If you're not used to working with Django, what's going on here is I define Django has an ORM for mapping classes to your database, and I define a user model which is going to correspond to a database table, and then Django allows me very conveniently to write queries, like database queries, using the syntax that's displayed below, right? So for example, if I want to find users whose username contains PyCon, right? Then there's this filter function, and the filter function accepts this parameter, which is username underscore contains. That function parameter wasn't written by me anywhere, right? The framework is dynamically adding this parameter so I can work with it. So a static analysis tool might complain, looking at the definition of the filter function, that this parameter isn't actually defined. So in that case, we would get a false positive error message. So when you start to try using static analysis in Python, then you need to know beforehand that many sorts of errors will be hard to find. But still, static analysis can still be extremely helpful. We and many other people have found that by integrating it into your development process, you can still catch many problems. If you haven't used static analysis, something like Pylint or some other similar tool, and you have a very large code base, you might be surprised to just run it and go around and look at all the messages that you get. You might be finding a lot of issues that need fixing. So despite its limitations, I want to highly recommend you that you try it out. I want to give some recommendations for introducing the usage of static analysis in your project. So the very first one would be, like, if it's possible for you, if you're thinking of starting a new project, then it's far better to start using it right from the beginning. And that means, like, from day one, in your development process, you need to start checking your code as you go. And that's by far the easiest way because as I was saying before, if maybe if you have a large existing code base, then you run Pylint on it or on any other tool, you will find thousands of errors, and then you're faced with the choice of fixing those errors or maybe telling the tool that you don't care about those errors, or maybe you just continue without actually using static analysis because the tool is reporting so much information that it becomes useless. So if you do it from the beginning and you make sure that your code is always passing static analysis checks, it's a lot easier. But of course, okay, so another useful thing is like integrating into your editor. Something, for example, Pylint has an integration with many different editors. At least probably the most popular editors are supported, right? So yeah, this is an example with VIM, which is what I use. And see here, like Pylint is telling me about like redefining a built-in function, right? That's another useful functionality of Pylint. Another important thing is like you should be doing it continuously and automatically. Meaning there's many ways to do that, right? So for example, if you have a continuous integration server, you could have a step which is like the static analysis check on the whole source code. You can have for example, we use Git as a version control system. If you use Git or any other version control system that supports hooks, like a push hook, then that's another way you could, if you could tell it before you push code to your remote repo, run static analysis check and fail if there's a problem, right? Or just putting it into your editor is another way to be running it automatically all the time, because as soon as you type something, it pops up that there's an error there, then you just fix it right now. And it's a lot cheaper to fix an error right now than in 2 months after the error was already introduced and it's running shipped in production. So there's another thing, which is basically we didn't do it from the beginning in like our main product at MakeLibs. So we did have the problem that when we decided, okay, let's introduce static analysis here, we had a very large amount of errors. I think the recommended way, after all our experience using it, is get your tool, for example, Pylint or Pep8 or whatever, to report 0 errors in your source code, even if that means telling the tool to ignore certain kinds of errors. So, for example, if you have a very large file and you run, I'm going to run Pep8 because I want to care about code style from now on, and then you get like 900 lines, right, of errors, then it's very hard to go in and fix all of those. So, for example, usually tools have a way to specify, you want to ignore certain kinds of errors, right? So here, Pep8 has this concept of error codes, which is also in some other tools. So like error E501 means like this line is too long. Okay, so I can say ignore error E501, and then I get a far smaller list of errors for my source code. And then maybe I can ignore, add further ignore statements, and then get a file that only has 2 errors. Then I can fix those, and then I achieved 0 errors in my code. Of course, that I'm just ignoring errors, so that still means the errors are still present. But it's a far easier process to manage if you got to 0 errors and then say, okay, now I want to make sure that this particular type of problem is not present in my code anymore. Then you just stop ignoring that error and fix your whole source code for only that type of error. And that's a far easier way to manage it. especially if you're working with many developers and you have like time constraints. You don't really want to stop the whole project just to start fixing errors in your code. So if for example, your continuous integration tool fails the build, if there's any error in the Pylint output, then at least you can make sure that you're not introducing more errors as you code, and you can just gradually eliminate problems as you go and as you find the time to do it. Yeah, before we used to have a Jenkins continuous integration server, and it has a plugin called the violations plugin, which reports code violations for many different tools and many different programming languages. So we configure it to do Pylint checks on all our source code. And then we got a very nice report like this, right? Like we get a source code file and then get all the warnings that are reported by Pylint graphically by line, right? So it's very easy to identify problems, right? And then what happened is we have this graph of the number of Pylint violations reported by our continuous integration server over time, right? So this is over a long period of time, the number of violations we have. And basically it's just an ever-increasing graph, because if you're getting thousands of messages in your tool, nobody's really looking at that. If you introduce an error, you're not going to notice, because it's going to be hidden deep within just a ton of all pre-existing messages. So rather than using a plugin like this, again, I would recommend that you just get it to 0 and decide like no build or no deployment of your project is good if there's at least one error message, right? And then that's far easier to start using it. Another thing that you can do to ease the transition is it's okay to be stricter with some modules than others. So, for example, it can happen that you have maybe some third-party code in your project that you have it, you took it and you put it in your main package. Or maybe you have automatically generated code. For example, people who use Django have the migrations files, right? Those migration files, you trust that they work correctly, and you don't really, they're auto-generated code. You don't really want to be checking them for like style, coding style violations. So you could tell Pepe, yeah, just ignore that module. But also, if you have your own modules that have many problems, right? Maybe you have 10 modules in your existing project, and then you decide, okay, I want to run Pepe on my whole project, and turns out like maybe your utils.py module has 1 million error messages, whereas the other ones don't have that many. Then it's okay to just ignore this module for now. Make sure that the rest of your code has absolutely no problems. So one way we did this is, okay, let's say, error E128 occurs too many times in utils.py, then I just check the whole project, ignoring that error, and then I just check the whole project again, selecting only for that error message, but ignoring the files where it occurs too much. And then you can have a very gradual process where you decide, okay, I will fix this file for this error. And then you do it, you get to 0 errors again, the build is fine, and no more errors of that type will be introduced in the future in that module. When it's reasonable, use an automatic fixer for existing code. For example, we used successfully a tool called PEP85, which just goes through all the source code and applies automatic transformation to make it really fit for example, the coding style standards. This in combination with gradual checking and being stricter with some modules than others allowed us to get our source code passing like style conventions over a period of time without interrupting work and without taking us away from building features or fixing bugs or other business concerns. And of course, this sort of tool is better. It's far better to use it if you're doing using some sort of version control, because then you can, after the tool run, you can see what changes it did, and then manually review them, because being an automatic fixer, of course, there's a possibility that it has a bug itself and it did something wrong with your code. So use disable comments sparingly. Maybe some of you already are aware of tools such as Pylint and know that usually checkers have a way for you to specify that you don't care about a certain problem in a particular file or in a particular spot in the file, right? So in this case, I could write a comment saying Pylint, like Pylint, don't warn me about an unused variable in this place. So that's useful because also, as I was saying before, there are many cases where a static analysis tool can go wrong because of the nature of Python, right? Maybe it doesn't, like the static analysis tool gives you a false positive, but you know that it is fine for this problem to be here. It's not actually a problem. So tools give you this way of telling, don't worry me about it. But we kind of recommend to use them very sparingly, because if you start using it everywhere, it kind of tends to litter your code a lot. And if you find that you're disabling a warning too often, then it just maybe makes sense for that project to ignore this type of warning rather than just have a lot of useless comments in the code. So as I've said throughout the talk, basically our current setup is we do a Pylint check and a PEP8 check on all of our Python packages, and we basically break the build if there's any problem reported by the tools. And we have our custom configuration file for Pylint especially, where we adjust the error messages to what our project should look like according to us. And of course, these tools are very configurable, so everybody has very different needs, but what I would encourage is you start using these tools, even if they can only find very small problems that you care about. It's better to have it in your project. And of course, it's also great if you can contribute back. If you think there's something that static analysis could automatically check for you, then contribute back, because these are all open source projects. Also, Python 3 is we had a keynote yesterday and talked about Python 3. So you may be wondering about Python 3 support. As far as I checked, we use Python 2, but Pylint, which is the tool that we use for automatic error checking, supports Python 3. So go ahead and try it out if your project is in Python 3. And that's basically it. If you have any questions, including questions about how to put hiragana in the LaTeX presentation, then
Any questions? Raise your hands, please. In Japanese.
So when writing code, personally, I mostly ignore PEP8. Do you have any opinion about? I think each row has a kind of weight. So, do you have any opinion about which rule is important, which rule is not so important?
I see. Yeah, well, I think our guiding principle, first of all, is for consistency. So, if everybody is following all modules are very consistent in whatever set of rules you choose, then I think that that's the optimal thing. In our case, basically, since Python already has a style guide that's official, then we try to stick to it. So actually, in our current code base, it follows very closely, even though we're ignoring some rules regarding like inline comments and spaces around inline comments, which are very minor things. But other than that, we kind of adhere strictly to PEP8. I think PEP8 is nice because it's something that everybody could be using, right? So if we bring somebody new into our project, they're already used to working with PEP8, then that's great. But yeah, I think I would recommend people to use PEP8 for coding style, but at least try to follow, be consistent. And also, this PEP8 checker tool is very configurable, so you could even maybe extend it to check for additional things that you care about. So, yeah.
Thank you.
Eh, 他にはありますか?
Yes, I was.
Pylint のDisable Unused Variables というコメントのラインがありましたよね。これは Pylint のみに対しておそらく有効なマジックコメントだと思うんですけれど、他のいろいろなツールで使えるようなそういったアノテーションっていうののなんか策定とかその決まりみたいなのはあるんでしょうか?
Yeah. Okay. So just to repeat the question, so it's like Pylint has these comments, that I talked about. So other tools have, this is particularly only for Pylint, but other tools have their own comments. So the question is like, am I recommending only for, like, not to use these comments only for Pylint?
Is there not such a magic comment for only for Pylint?
Yeah. Yeah.
But also any lint programs magic comment I wanna use.
Right. So multiple tools have multiple ways to specify, like for example, PyFlakes might have its own way to put disable comments. There's also like another convention, which is to put a comment at the end of the line with the text like no QA, meaning like you don't want any checker tool to, you want any checker tool to ignore that line. But as I was saying before, I think it's important to use these types of comments as little as possible, because they tend to, you're paying a price by using these comments, which is like your code is now littered with a lot of comments that are not about whatever thing you want to be solving with the code, but just about telling this tool that's not as smart enough to find out what you want, that you don't want any message here. So I think for any tool, I would recommend to try to, it's not forbidden to use it, but just try to, I mean, we use it sometimes also in our projects, but for example, Django settings files is a place where we use it, if you're familiar with Django. But yeah, in general, I would just recommend to use it as little as possible, regardless of the tool.
I see. So thank you.
Okay.
はい、他にはありますか。はい、そこで。
Thank you. Thank you for your interesting presentation. Anyway, I want to know, why do you choose the Pylint and the Pipate?
Yeah, good question. Yeah, we found Pylint to be to find a very wide range of problems in our code base compared to other tools. If you start searching for tools that can do static checking, you will find many. First of all, for example, there's this tool called PyChecker, which actually does an import of your code to check it, meaning that if your code has side effects at import time, then this will get run. So if in a code large enough, maybe you don't want to be doing that. So that was the case for us. So that rules out certain classes of checkers. So for example, Pylint and PyFlakes, which we found to be very popular in general, don't have that problem. And then comparing between both of them, we just went with Pylint, which found a very large range of problems. I can give some examples, like if you use like the Python logging package, there's like you can do a logging statement with a formatted string. So you can say, okay, whatever happened, do string formatting to put it in, and then you can do the string formatting yourself and pass the formatted string to the logging statement, or you can you can pass the arguments to the logging function, and it will do the formatting itself. And it's actually, the second option is a lot better, because it means if there's the logging function might decide to do or not do the logging depending on the log level that you're at right now, and maybe it will save itself the formatting cost of processing, or even like if there's a formatting error, it will not happen if the log line wouldn't have been output anyway. So for example, Pylint found that sort of problem. It helps us find duplicate code, which I mentioned. It helps us find some coding style problems too. So it's a pretty varied wide range of problems that it can find. And it's also pretty much in very active development too, which was the other important thing. Even since we began using it, there have been like new releases, and we even have had it happen where we just upgrade Pylint, and then the code that we were using before normally now is reporting some error because some additional checks were added into Pylint, and then that's very important to. So yeah, all of that together made us choose it.
Thank you. Yeah, you mean that you wanna gather a lot of errors or warning by using the Pylint, and you will choose or select by using the ignored error numbers, right?
Sorry.
That you gather a lot of errors or warning by using the Pylint, and
Right.
You will choose the error number for ignoring.
Right, I mean, yeah, like we when we began using Pylint, we had Pylint reported many problems. Many of them were not actually problems, but most of them were. So yeah, we just, as I said, after a while of just having a report of problems after every build, which basically all developers were just ignoring, including myself, because it's just too much to deal with. We decided to just ignore all errors and have Pylint report 0 problems, and then just work on removing the errors that Pylint ignores.
Thank you.
Yeah. 他にありますか？ないかな。そう、
Okay.
なさそうなのでちょっと早いんですけども、じゃあ発表をこれで終わりたいと思います。So give him big hands and yeah.
Thank you.
ありがとうございました。この後、コーヒーブレイクがあるので、コーヒーを飲みたい方はそちらの方へ向かってください。